Welcome to Get Your FRQ On. This question is from 2011, Form B. It's question 2, and it is calculator active. In the question stem, we have a 12,000 liter tank of water that's filled to capacity. We're given that at time t equals 0, water begins to drain out of the tank at a rate modeled by a function r of t, which is a piecewise defined function. In part A of this question, we are asked if r is continuous at t equals 5 and to show the work that leads to our conclusion. Now, in order for r of t to be continuous at t equals 5, we need the limit as t approaches 5 from the left of r of t to be equal to the limit as t approaches 5 from the right of r of t, and for both of those to equal the actual value r of 5. However, if we find the limit as t approaches 5 from the left of r of t, that's 3,000 over 8, which is 375, and compare that with the limit as t approaches 5 from the right of r of t, which is 1,000 e to the minus 1, that is definitely not equal to 375. So the two limits are not equal. And because the two limits are not equal, we conclude that the function r of t is not continuous at t equals 5. In part B of this question, we are asked to find the average rate at which water is draining from the tank over the interval from 0 to 8 hours. So the average rate at which water is draining from the tank is given by the integral expression, 1 over 8 times the integral from 0 to 8 of r of t dt, which is 1 over 8 times the integral from 0 to 5 of r of t dt, plus the integral from 5 to 8 of r of t dt. And because this is a calculator active question, we will use our calculator to evaluate the integral. So we have 1/8 times the sum of the two integrals, the integral from 0 to 5 of 600t over t plus 8 dt, plus the integral from 5 to 8 of 1000 e to the negative 0.2t dt, and that turns out to be 258.053. So the average rate at which water drains from the tank from t equals 0 to t equals 8 hours is 258.053 liters per hour. In part C of this question, we are asked to find the value r prime of 3 and to explain its meaning in the context of the problem along with the appropriate units. And since this is a calculator active question, we will use our calculator to evaluate r prime of 3. It turns out that r prime of 3 is equal to 50. So this means that at t equals 3 hours, the rate at which water is draining from the tank is increasing by 50 liters per hour per hour. In part D of this question, we are asked to write an integral equation that can be used to find the time A at which the amount of water in the tank is 9,000 liters. We are given in the question stem that the tank contains 12,000 liters of water at t equals 0. And by doing a little bit of basic math, we can determine that the tank will contain 9,000 liters when 3,000 liters have drained. Putting this all together, we just need to know when the integral from 0 to a of r of t dt would equal exactly 3,000. Keep in mind, we do not need to evaluate this integral or solve for the value of a. We just need to write the integral. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.